everybody. Thank you for joining me on the last day of GDC, creating your own shaders using Unity Shader Graph. I'm Liz Mercuri. I'm from the Evangelist team in the UK, so it's great to be here. Thanks for joining me. So does anybody here, have you used Shader Graph before? A raise of hands if you have. Perfect. This is brilliant. Okay. Yes! I also enjoy audience participation. So yeah, that's great then, because the agenda of this talk is actually just building up from scratch. I'm going to go over what it is, how you make a shader graph, and just making a really simple shader to start with, and then we'll look at some more complex use cases. So such as like a toon effect, and also this like moving crystal here. So yeah, and then I'll give you some resources to go away with that you can carry on at home. So what is Shader Graph? Shader Graph is a node-based system that allows you to create your own shaders, code-free essentially, which is cool. How many artists are here? Raise of hands. Cool. Programmers? Cool. There's some bits for you at the end which you can go away with, which is cool, because it's quite extensible as well, so I'll give you those resources. So it's made up of a few components. The first is this master node. So the master node is where the final shader is represented. And if you've made materials in Unity before, you may find it familiar with like your albedo and your metallic and that kind of thing. So this is like where your final shader will show itself. Then we have the actual nodes that you can start to create your shader. So each node has an input and output, and essentially you can chain them together to the master node, and that visual display will flow through the nodes, so you can get instant feedback of how your shader is coming along. There's also the preview node too, so if you have a particular model that you're wanting to preview, you can load that in. Finally, something that's really important for your workflows is you can actually expose properties of the shader graph to the editor using this blackboard. So at the moment on this screenshot, you can see that we have this property called red mage texture, and that's actually going to show in the editor, so you can change the texture from there. You can get shader graph now from the package manager. So it's just Windows Package Manager from the Unity engine, and you can get started with that straight away. So, let's, oh, yes, just one thing to bear in mind, sorry. So it's available now, Unity 2018 and later, but it's only compatible with our new render pipelines, which is our lightweight render pipeline and our high definition render pipeline. So if you're on an older version of Unity with the built-in render system, you won't be able to use shader graph. So just an FYI. So let's make some shaders. Woo! Yes! So, got this little project here. So this is from a tower defense game that an external crew created for us. So I've got a few things in this scene. The first is that I have this kind of toon effect here, so you can see with the little archer, that if I move the directional light, that the shadows on the archer are like real solid, like this cut-off toon effect, as opposed to that of the tower in the background, which is a lot softer. So we're going to go through the graph of how this toon effect is put together. Then at the back here, we have this crystal. We can actually use shader graph for vertex displacement to create movement, so we're going to have a little look at that. And then also, there's this cool refraction effect. There's a single node in shader graph that can allow you to achieve that. So we're going to have a look at that too. Well, it's a collection of nodes, but this is the big one. But what I'm going to start with, just so we can like build a shader from scratch together, is if I go into play mode, we have this little mage character at the front. And if I click on them, you can see that they change to this blue texture and it has this glowing outer edge. So we're just going to recreate that. We're going to make a simple texture and just have this like glowing Fresnel effect. So, live demos, what could possibly go wrong? Let's get started. So we can make the graph by right-clicking in the project window, create, and under shader, there's a selection of graphs. So we have our PBR graph, and we also have unlit, but we also have subgraphs. So if there's some functionality that you're wanting to reuse across your graphs, you can create a subgraph to do that. So we're just going to use PBR for today, and I'm just going to call this GDC Mage Shader Graph. Why not? And then we can just right-click to open it. And we'll see this like familiar layout from before of the master node, the blackboard, and the preview node. So I'm just going to dock it down here, and we can get started. It's our little mage. So have any of you here written shaders before? Amazing, cool. So the way that I learned shader graph is I actually kind of went through shader code. If there was an effect I really liked, I would go online, I would find the shader code, and I'd go through each line to see if there was a corresponding like node for each like shader keyword, and I built up my shaders that way. So just wanted to throw that out there as a recommendation, because that's kind of how I learned. I know people learn differently, but so for example, if I wanted to sample a texture, we're going to start by just adding the texture here. We can right-click to create a node, and there's a multitude of different nodes. So we have nodes for mathematical effects, we have inputs here, lots of artistic things, so normal maps, we can make blends, but we can also search in the bar at the top. If we want a texture, we can sample a texture 2D, and we can add that there. So you can see now we have this node with its inputs and its outputs. So we can use this input here to add the mage texture. And then we can simply take this and just pop it into the albedo. We can see that now our preview node is updated, and also our master node. To add this in the editor and see it in action, you need to save your asset. And then we can navigate to our mage here. And we have this whole list of shaders that you can use. So one of the cool things about shader graph, to keep things neat, is that back in here under the blackboard, you can specify a file path. So I could say GDC shader fun. Save it. So we're changing the material from the shader from this shader drop down here. And now we can see I have this subheading of GDC, shader fun, and the shader graph that we're working in. And it automatically updates. We can add a normal map in the same way. So we can search for that texture 2D, add our normal map. Yep. And then we can just adjust the type here to be normal. Again, we can just plug that in, save our asset, and we can see that it's updated here in the editor now. So, simple so far. So how about if we're working with a team who don't want to always be in and out of shader graph? We can expose these editors in the blackboard. So let's take a look at this mage texture, for example. We can go to the blackboard and select this plus button, and we can see that there's a whole host of values that you can create. So we want a texture. And we can have it exposed in the editor, call it mage texture. We can even set a default. And then all we need to do is drag it into the graph and plug this into the texture node instead of that hard-coded value. Save the asset. Return to our mage. and we can see that we now have this mage texture. So, for example, at the moment there's no texture there, but we can then select this mage. So that's the way to expose your values from shader graph in your editor. And as you can see, you can do this for a multitude of values. So what about the glow effect that we saw at the beginning? Well, luckily, there's a Fresnel node. So again, we can search for this. And we can see that the Fresnel has this fade from white to black, so we have this outline. We can take this and we can just plug it into our emission node. Save the asset again, updates in our scene. Getting the gist of the kind of iterative workflow here. So what we can do here is we can have this Fresnel effect like flash over time. And we can do this in a number of ways, but one way that I thought was just quite a more simple way to demonstrate it is we can actually create a time node. And the time node has lots of different options. So we can do time, like delta time, but also we can pass it through a sine wave. But if that's not what you fancy, there's also a sine node. So if over time we pass through this sine wave, we can see that we get this preview in the editor, in the graph. So the sine wave is sort of moving between -1 and 1 in this kind of sine wave, and that's the effect that we're getting here over time. So then what we can do is multiply the output of this sine wave over time and the visual effect of the Fresnel. And we can see this updating here. We can right click to delete the existing connection, and then we can take this output and post that into our emission. It's so small on the screen. There we go. Let's save this. And then we can see that now updating over time. I use the multiply node so much more than I probably should. So for example, if we sort of look at this here and we're like, okay, this is cool, but we want it to be able to flash a little bit faster, we can maybe expose vector 1, so a float, which is like flash speed. Drag this in. And again, use our handy multiply node. To multiply time and this flash speed into the sine wave. And then again, with this exposed in the editor, we can set this flash speed to super high. So the multiply node is super useful. You can use it in the same way, like if you wanted to add a color to the Fresnel effect as well. Just one last example. I'm a big fan of the multiply node. So we could expose a color here and say that this is, let's rename this to like glow color. I'm going to use American spelling because I'm here. And again, we can use the multiply node here, so we can get the effect, the output of the glow color with that of the Fresnel effect, and then pass this. So you can see that it's really quickly, if you're trying to get a certain visual style, to just plug and play and get that effect. So now we can put the glow speed up, and we can also alter the time, the color, the glow color from here too. So yeah. So that's super quick from scratch, how you can sort of visually build up your shader in that way. What I thought would be cool now is if we looked at slightly more complex examples, but they're all using the same kind of base logic. So the first one that I think is really cool is the toon effect that we have going on here. And that's because you're not constrained to just exposing values to the blackboard to use in the editor, but you can also use them in script too. So if I just look at this toon effect that we have here, the way that it's working is that we have this script on our directional light, and the script is referencing this value called light direction. So the script looks like this. So if any of you have written shaders in Unity before, the shader set global vector may be familiar to you. But what we're doing is we're taking the transform of the light and we're storing it in this light direction property from the blackboard. So we can actually use this in our shader graph. Oops, did not want to do that. So if we have a little look back at the graph, we're taking our light direction and we're taking the normal vector of our object in world space because the light is moving in world space. And then we're passing it into the dot product node, which is very common in shader writing, so I'm glad it's there. And so what the dot product is doing, like for those of you who may not be familiar, is it's working out whether two vectors, in this case the light direction and the normals of our object, whether they're like 90 degrees to each other. And based on that, it's going to give a range between -1 and 1. A lot of the nodes in the shader graph use values between 1 and 0. So we have this handy remap node, which allows you to be able to remap the values from one node output to another so that you can easily use them in the flow of the graph. And then to achieve that toon effect, we're using a sample gradient node. And if I just open this up, you can see that we can set the color. So from the output of our dot product, 0 is going to be our blackest black there, all the way up to 1, which is going to be our bright white. So our gradient of this like shadow effect. We can create a blend or we can create fixed, which is quite nice for more like a more toon effect. He's so cute, or she. Then we're using our handy multiply node to multiply the output from the texture with that of what we've just worked out for the gradient. We're also using the normal map as before. And then we've got this extra property here called toon emission amount. And that is, I'll show you. This is so this is plugged into the emission of the master node. And this is just to add more contrast to that sort of gradient effect shading and the actual color of the texture. So again, the way that we've kind of achieved this toon effect is by taking a dot product of an exposed value that we've exposed in script and the vector, the normal vector of the model, and we've passed it into this sample gradient node. Again, there's many different ways to create toon style shaders using shader graph, but I think this is quite a nice introduction to it. So the final thing that I want to show you is this gem. So there's a couple of different things going on with the gem here. The first is the movement, and the second is this refraction effect. So first, let's have a little look at the movement. So the master node, whether it's unlit or PBR, now has this position effect, position node. So we're able to affect the offset, the vertex position here. So let's go through and see what's happening. It looks like big and scary, but once we go through it, it's quite nice. So we're taking our time, and we've exposed this value in the blackboard of the crystal move speed, so how fast we want it to move. Let me get these exposed. Here they are here. We're multiplying that, like I like to do, and we're passing it through a sine node, just like before, so we're getting that ping of movement. Then what we're doing is we're multiplying this with another exposed float, which is how far we want that crystal to move. And then finally, the bit that I think is the coolest is we're taking the object position with the position node. So you can do this for view, world, and tangent. But in this instance, we want the object's position. And we're using the split node. So the split node is really useful if you're just wanting to work on like a single channel. So if you've got, what are they called? The maps that have like ambient occlusion, metallic, I forgot what they're called. Escaped me for a second there. But saying that you want to like separate your RGBA or your XYZ, you can do that with the split node. So what we're doing here is we're splitting out the y-axis, which is the movement, the axes that we want the crystal to move on. And then we're using an add node to add the effect of that calculation to the y-axis only. And then we're combining the final vector back together at the end with the combine node, which we can then just pass into the position. So if we wanted, at the moment the crystal's moving on the y position, on the y-axis, but if we wanted it to move side to side, we could, let's just delete all these. Let's plug the y-axis into here, so we're adding all the logic to the y-axis. To the x-axis, sorry. So now we're adding all those values onto that x-axis, and then we just need to marry up the y and z with the combine node, and we should see our crystal now move side to side. There we go. Oh no, have I got it on the wrong axis? You get the idea. So that's the movement. So the way that we've done the movement is we've got time passing through a sine wave as before to get that ping of movement. We're exposing a couple of parameters for the speed and the distance, and then we're using the split and combine nodes to be able to isolate the axes that we want that movement on. So finally, I'm just going to show you how we've made this cool refraction effect. Let's slow that down a little bit. So, we have this value here, which is the normal map intensity. And if I put this to 0, it's a little bit clearer to be able to see through the crystal. If I ramp up the normal map intensity, you'll see that we get this more like broken, jagged, like fractured glass effect, if you like. So what we're doing here to create this is we're using the screen position node. And what the screen position node does is it takes like the UV of the screen and it overlays it on the object. So in this case, our crystal. So let me demonstrate. So if I remove the screen position and save the asset, you'll see that we're not getting like the scene reflected back on the crystal. It's just like a plain canvas. But with the screen position node, we're able to take that UV of the screen and like wrap it here, just to create like a reflection kind of effect. Then we're using the normal map as usual, but we're exposing this normal map intensity value. So we're able to like distort the normal maps even more. And that's creating this like crystalline effect. The cool thing that we're using is the scene color node, which is super new. I think it was 2018-3 that it was introduced. And if any of you have maybe done like glass or water shaders before, where you use the grab pass and then the use pass, which can sometimes be quite like expensive. The scene color node basically combines those two things. So it kind of draws all the opaque geometry and then allows you to like overlay these effects like reflection or refraction. So you can use the scene color node to create like glass effects like this, but also water. So what we've done is we've taken the screen position, added it to this normal map, like distortion effect, and passed it through the scene color node to then overlay this effect. And then we've passed that into our color on the unlit master. Something else we're doing in here, again, like with the handy multiply node, is we've got a HDR color here exposed in the blackboard. And we're just multiplying we're using this to like multiply the intensity. So here, for example, we can change the glow effect. So you really can just kind of like add nodes, see what happens, play around. You can create some crazy effects like by accident that you're like, I'm going to keep that, that's cool. So yeah, so just the recap of that, screen position and scene color to get this refraction effect. So, just in summary, so ShaderGraph is a node-based system for creating shaders, and you can get it now from 2018-1 on one of our lightweight or high-definition render pipelines. For the programmers that were here, the ShaderGraph nodes are extensible. There's an API for you to create your own nodes. I used the multiply node so much that one of the guys in my team, my last name's Mercuri, and he made a many Mercuri multiply node because I used it so much. So you can use it for all sorts of stuff. And you can also get the output of the code. So if you've generated something in ShaderGraph and you maybe want to look at how to, like, if you could optimize it or add some tweaks, you can output the shader code too. These are some good resources. So you can kind of see this faded image in the background. This is our ShaderGraph sample library. So there's like hologram effects. It's being updated with all of the refraction effects. There's fire effects. There's all sorts. There's so many nodes that we have documentation. So if there's something that you're wanting to, an effect you're wanting to create, you're not sure how, go along to our documentation. It has all the nodes there. The blog to create your custom nodes is here. And then we have a blog post of what was new in 2018-3, including our high definition lit master node as well. So lots of things coming and for you to play with. Yeah, thank you for listening. Yeah. Oh, questions.
So that what you just showed, is that part of the example library? Or is that something separate?
This project was one that I just kind of made. So the example library is being updated all the time. You can download it from the GitHub, and there's lots of different branches. So these effects, like the refraction and using the screen color, they're all on the 2018-3 branch. So you can like download those. And the effect that has is it has lots of different statues, and there's like a like glass statue and a marble statue, or like different effects. I didn't make that though.
I was wondering if you could go back to the demo. There's one spot I would like to see what happens if you take out a certain node there.
Sure.
That was, if you take out the scene color, what does it do? I'm curious what yeah, just. And then you can just save it. You have to save it, right, after?
Where's the normal there? It's just flat. Just get the flat color.
Okay, thank you.
Can the ability within the shader to move positions, can I move that either per vertex or per pixel within? So in this case, we're moving the entire object.
Yep.
Can I move just certain vertices, or can I move certain pixels if I have the right kind of graph?
The way that we kind of I'd be able to ask the guys that have played with it a lot more, but the way that I kind of have been doing it, like this bit that's not plugged in, was to get the crystal to move on one axis, but then to get its kind of like this. So let me see if I can plug it in. And again, it's kind of like reusing the same logic of getting the object position and so at the moment, let me ask the team, but the way that I've been doing it is like reusing the same bits and adding it in and seeing how it kind of affects it. But I can check, I can find out for you.
Yeah, 3 questions. First of all, will this be production ready in 2019.1? Great. Second question, will this work just as well with the LWRP as much as the high definition render pipeline?
Yep, the shader graph was first kind of road tested with lightweight render pipeline, and now with the high definition render pipeline. So yeah, it's good
Great.
to go.
So it works just as well with both.
Yep.
What about the default render pipeline?
This does not work with the
Okay, good to
default
know.
render pipeline.
Yeah, I probably won't.
Nope.
Yeah.
Nope.
And then last question is workflow with Substance Painter.
Oh, okay. Don't know.
Okay. It's okay. Yeah,
Just
I'll ask
being
someone
honest.
else. Thank you.
I can find out for you though. I think there'll be someone on the artist tools section who'll know that, so I can take you over and find out.
Thank you very much.
No problem.
Thank you.
Thanks everyone. Thanks for coming along.